Yo, 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 it's big time math coming back to you with A12B. Evaluate functions expressed in function notation given one or more elements in their domains. When I see the word domain, I think of the variable x, and x is our input. So what we're trying to find is the output. It's our function notation. Let me show you. So function notation can be rewritten as f of x equals y. So this is your output. This is your output. And if you look at the x is inside the parentheses, so I kind of like to think of that as the input. It's inside. So whatever the x value is, I'm going to plug that in for x to get my f of x or get my y. So what does that mean? So if I have a function written as, say, y equals 2x plus 5, I can rewrite that bad boy as f of x equals 2x plus 5. Now, whatever this x value is, let's highlight this mug right here. Whatever this x value is right here, I'm going to substitute in for this x value right here. And then I can evaluate the function to get my output or my y value. So let's check out some examples. So this first example is f of x equals x plus 5, and I want to find out what f of 2 is. So remember, the x and the 2 are in the exact same spot, so that is technically my x. So what I can do is substitute that x value right there. So it's 2. So I can rewrite this. Instead of writing x, I can say, well, 2 plus 5. Now there's nothing on the outside of parentheses, so that doesn't change. So 2 plus 5 is 7. So technically, I can say f of 2 equals 7. See how that works? Now, if I wanted to rewrite this as an ordered pair, this is how really cool it is. Remember that this is the x value. So if I wrote for the x value 2, I get an output or a y value of 7. So there's my x and there's my y. Let's try another one right here below it. Still got the same function, f of x equals x plus 5, but this time I'm saying I want to find f of negative 4. So this is my x value, so it's going to go right there where the x is. So I can rewrite this as, and I like to use parentheses when I'm substituting in just because there might be something on the outside of the x, or the x might be squared. So we'll do this. So there's nothing that's going to change this first parentheses, so negative 4 plus 5 happens to be a positive 1. So I can technically say f of negative 4 equals 1. So my x value of negative 4 will give me an output value of 1. And if you want to write that as an ordered pair, you could say negative 4 gives me positive 1. So what you're doing is taking the number inside the parentheses, plugging it into the function, and evaluating. Let's try a couple more. So right here, I have f of x equals 3x, or 3 times x minus 2, and I'm looking for f of 7. So 7 is my x value. It's going to take the place of that x right there. So I can technically say 3 times 7 minus 2. Now, there's nothing in front of that 7 inside the parentheses, so 7 minus 2 is 5. So I can say 3 times 5, and 3 times 5 is 15. Okay? So I can say f of 7 equals 15. So for this x value, I get an output value of 15. So I could say, well, 7 gives me, oh, let's make that a little bit better there. So 7 gives me 15. You see how that x value gives me an output value or y value of 15. Uh-oh, now we got up in here fractions and negative numbers. Holy moly. And the x is on a different spot. So let's check this out. This is still my x value. So what is, if I'm given the function f of x equals 1/4 times 5 minus x, find f of negative 3. If you want to pause it and try this problem on your own, go for it. So I'm going to look right here, bam. So I'm going to say, well, it's 1/4 times 5 minus a negative 3. Now you see how I use parentheses there? That way I don't mess up and think that negative and minus are the exact same thing. They're two different things. But we know that a minus and a negative turn into a positive. So I have 1/4 times 5 plus 3 is 8. And remember, we're trying to find f of negative 3. And so 1 times 8 is 8, so that's technically like 8 over 4, and 8 over 4 is 2. So I can say that f of negative 3 equals 2. So there's my x value. So that means we have, for the input value of negative 3, we get an output value of 2. All right, so there's our input, our output. Now, what if we are going to look at a quadratic, okay? I don't want you to be scared of quadratics. It's the exact same work, except you're adding in a squared. So technically, if I've given you the function f of x equals 2x squared plus 4, I still am looking for a value of, in this case, 5. So what is f of 5? So I take that 5 value, plug that in. So f of 5, I could say f of 5 equals 2 parentheses, this is where parentheses come in handy, squared plus, well, in this case, 4. All right, and so we know order of operations that we're going to do the exponent first, so 5 squared is 25, so I can say, well, 2 times 25 plus 4, and 2 times 25 is 50, and 50 plus 4 is 54. So f of 5 equals 54. And again, if you want to rewrite it, you could say, well, for my input value of 5, I get an output value of 54. So this x value is that y value. Now you see how I wrote these in ordered pairs, and it comes in handy when you're looking at a graph. Let me give you an example here. For example, if I'm looking at this graph and I say find f of negative 8, and I'm not given the actual equation or function, well, we know that f of negative 8, the negative 8 is the x value, correct? So if I can find the x value of negative 8, then I can find my y value. And so I go on my graph over here and I go down to negative 8. So here's negative 8 on the x-axis. And when I go down, bam! Okay, I get that number there, and it just so happens it's negative 2. So if x is negative 8, then my y value is negative 2. All right, now if we look at this next value, it says find x if f of x equals 6. Now, you remember earlier I said f of x equals y. So if this is saying f of x equals 6, it's technically saying y is 6. So if I go to my y-axis and I go up to y and I look at 6 and I go over, bam, there's my value. And so that value happens to be 8. So the x value is 8. And if you want to rewrite it, you could say, well, f of 8 equals 6. And look, there's x, there's y, and we could test it, go over to 8, up to 6, and it lands right on the function. So the answer here would be 8. All right, that's how you do it looking at a graph. And if you want to look at a table, we could definitely do it that way also. Same process here. So it says find f of 0. Well, we know 0 is the x value. So if I go to the x side of the table and I go down, here's 0. What does 0 give me? It gives me a 7. And then it says find x. So now what x value is given when I have f of x equals 3? So we can say, well, y is 3. So if I go to the y side, and here's 3, so what x value? So I could say, well, when x is 7. So technically, it's like saying, well, f of 7 equals 3. So if x is 7, y is 3, and look, when x is 7, y is 3. So there are two answers there. All right, you can go back and rewatch this video to get any help on that. Remember, we worked with functions, we worked with graphs, we worked with tables. So A12B, evaluating functions, given a domain value. It's pretty cool. All right, good luck, folks. See you next time.